So I'm saying for today's class, we said we are going to look at bivariate data. So I've indicated this as chapter 4, simply because I shared some notes. I hope you all got the notes that I shared. So I shared the chapter 1 notes. That is basically theory. So that one you just need to read. What is statistics? Different categories of statistics. Methods of data collection. And again, the methods of data sampling. Then I also share some notes on data presentation, the ones we did last week. But that will be for the purposes of, say, the assignments that you're going to do later. And for this one, again, I'll also be sharing some notes as we move where necessary. So today, bivariate data. So in the past, we've already considered one set of data, and we've done some numerical calculations for that, numerical summaries. So we did the mean, we did the standard deviation, we did the quartiles, the percentile, the deciles. We're able to group the data into frequency distribution table and so on. So here we are considering two sets of data. Say we have a set of data X. So you have X1, X2, all the way up to Xn. We have another set of data. We have Y1 all the way up to Yn. And so, for example, we can be talking about marks obtained in two subjects by 60 students in a class. So say you have one subject in mathematics, another one in business also. And then you try to find out whether there is any relationship between the two subjects. So previously you used to hear if, like when you are in high school, the chances were that if you are the kind of person, that fails in mathematics, then there are also chances that you also fail in chemistry. So there were those instances. Then you may find that you are the kind of person that do pass well in mathematics. Then when it comes to languages, you're not so good in that. So you can try to find if there is such a correlation. Then when you talk of sales revenue, when you talk of, can you mute Maureen? You can mute. So when you talk of sales revenue and you talk of the advertising expenditure, you want to see whether there is any relationship between these, whether once you increase the expenditure on advertising, whether that is going to bring you more revenue. Then the age of husband and wife, you want to see whether there is any relationship between these, where you have, say, if the age of the husband is higher than that of the wife, does it always, is it always like that, that the husband has to be older than the wife? So we can do that with statistics and find out whether there is such a relationship. Now, there are two ways to this. One is using the scatter diagram, and the other one is using correlation. So scatter diagrams is where you use the graphs. Then when you talk of correlation, now you bring in the aspect of the mathematics bit of it. So we are saying you are able to plot two values one in the horizontal axis and the other one is on the vertical axis. Then the value on the horizontal axis is what we refer to as x. So this is what you use to do. X is it is plotted on the horizontal axis, then y goes to the vertical axis. Now down here, we're saying two variables are said to be correlated if the change in one of the variables results in a change in the other variable. So that is the only time you can say that they are correlated, if the change in one variable causes a change in the other variable. And that is to mean, say, if one variable increases, then you check whether the other variable, does it increase or does it decrease? Now, we talk of two aspects of correlation, and we say if two variables deviate in the same direction, that is, if an increase or decrease in the values of one variable results on average in a corresponding increase or decrease in the values of the other variable, the correlation is said to be positive. Now, here we have two aspects here. We are saying if one variable increases, then if the other variable again increase, so I'm omitting what is inside the brackets. So I'm saying if one variable increase and the other variable, or it causes the other variable to also increase, then we have a positive correlation. But in the instance where you have one variable increasing and the other variable decreasing, then at such a point we say we have a negative correlation. And we are going to see how that happens. So examples of positive correlations is where you have the height and weight. So you remember me asking you in the previous class whether your height correspond to your weight, because many instances you find that as you increase in height, your weight also increases. So I don't know one instance where your height is decreasing and your weight is increasing. The other way around, I have not seen such an instance where the height is, or possibly at old age, you may find that someone's height is decreasing, and so is their weight. Okay, but now this is when you hold all other factors constant, because now your weight could be affected by other factors, possibly illness or something, and so you end up losing weight. Then you might also be eating a lot, such that even when you are considered short, your weight is too high. So at such a point, we say that someone possibly is suffering from obesity. They are overweight and such. Another instance is the household income and expenditure. Now, this is true because once, say, you are earning 20,000, you're likely to spend only as much as the 20,000 allows you. But when you start earning, say, 50,000, then you again increase your expenditure. And you find yourself now spending over 40,000 and such. Okay. Yes, Davina. Davina, you are saying? You can unmute and say.
I'm sorry, it was an accident.
Okay. So the income, even you yourself at school, you may find yourself in the very start of the semester. your income is higher. Now your income now here is the, say, the pocket money. And so your expenditure is also high. This is the time you're eating all those snacks, all kinds of the snacks that you find around, including chicken and the like. But towards the end of the semester, your income is a bit low. And so at such a point, the expenditure is again very low. So if you consider price and supply of commodities, if the prices are high, you may find that the supply, those supply might tend to add more supplies or more commodities. Once the price goes down, they try to withhold some of the commodities until the price again can go up. Then when you talk of amount of rainfall and yield of crops, this is something that you are witnessing now. Due to inadequate rainfall, we do not have enough yields. The yields are very low, and so on. So correlation between two variables is said to be negative or inverse if the variables deviate in opposite direction. Now, we can demonstrate this now using these graphs here. These graphs. So we have graph number A. So we are saying that as the value of x increases, the value of y increases. You can see that it's moving from point A to B. So you can see once you plot the value of x is equals to 2, and y is equals to 3, x is equals to 10, y is equals to 10 at that point. So you can see you can be able to draw a straight line going up. So the value of x increase, the value of y increase. For this instance here, we have a negative correlation. The value of x is increasing. So you can see it is from 0 all the way up, it is increasing. But the value of y is decreasing. So it started at high point here. Then once you move along this, it is decreasing. So find that the last value is here. So we say that this is negative, but linear. You can be able to draw a straight line to show that or to demonstrate that. Then we have this other instance here, C. We are saying as, again, the value of x increases, the value of y decreases. But once you try to draw a line here, you find that this line is non-linear. It's not a straight line. It's not a straight line. Then we have the last instance here where we say there is no relationship. So in this instance, you cannot tell whether there is an increase that is causing a decrease, or there is a decrease that is causing an increase. You cannot easily tell. So it is just scattered without any direction. So at such point, we say there is no relationship. So that is one way to demonstrate correlation, or how two variables relate. So how do you interpret this? We say you can have all these scenarios. You can have a strong positive correlation. So that is the time when you clearly can tell that the value of y is increasing with the increase in value of x. So if x is increasing and y is increasing, then you have a strong positive correlation. You can clearly tell. You can clearly tell. Now, we also have a strong negative correlation. Again, this is when you can clearly tell that the values of y are decreasing when the value of x is increasing. So that is this instance here. We have seen this here. As x increases, y decreases. So you have a strong negative. You can also have a weak positive. So again here, it is just slightly. So here we use the term slightly. Y increases slightly as the value of x increases. Then the weak negative, again, the decrease. So we have a slight decrease as x increases. But then we have a complex correlation. The value of y seems to be related to the value of x, but no relationship. can be determined. Okay. Yeah, it seems to be related, but you cannot clearly tell. Does it? So you can have it as, so this one, you find that it is basically just a straight one, a straight line, possibly parallel to this x. So you can see clearly x is increasing, but you cannot tell what exactly is happening to y. So at such a point, you have a complex correlation. Then, of course, no correlation, you cannot tell totally. You cannot tell, like this case here, you cannot tell totally what's the direction. So that is the graph representation of correlation, seeing whether the change in one variable causes the change in another variable. Now, we can also talk about correlation coefficient. So this is now the mathematics bit. This part here is the mathematics. And we are saying that correlation coefficient measures the degree of linear association between two paired variables. So we want to establish whether there is any association between these two variables. So my internet is blinking. I hope you can still get me. So we are saying that these values, the values of correlation coefficient run between +1 and -1. So any value that you get outside this is wrong. So it has always to be between -1 and +1. And we denote correlation coefficient with small letter r. You can see here. So we are saying there are three scenarios that you have. If r is equals to +1, strictly +1, we have perfect positive relationship. Perfect. So when it is +1, but when it is -1, again, exactly -1, you have a perfect negative correlation, a perfect negative relationship. But when it is 0, then at such a point, there is no relationship. The variables are uncorrelated. So that means you can get values between -1 and +1. So you can get a negative, say -0.5, -0.21, and so on. You can get 0.5, you can get 0.6, 0.2, and so on. So with all those values, you can easily be able to explain what that value means. Is it positive? So if it is positive, then it means once. So so I can see we are notified. We only have less than 10 minutes to this. So this is where I was saying, if in any case this goes, we lose the connection, you again click on that link, it is still going to take you back here. So remember that. So now we have various types of correlation coefficients. One of them is what we refer to as the Pearson's product moment correlation coefficient. Pearson's product moment correlation coefficient. So this one, again, we denote this by R, small letter r. And again, it's a measure of association between two variables. Like we said, the weight and the height, and so on. So here is the formula. So it looks a bit bigger. Can you see this formula here? So give you 10 seconds to possibly write it down. So you're saying R is equals to, so we have a fraction here. In the numerator, you have n summation of x, y, minus summation of x, summation of y, the whole of it divided by square root. So this square root sign covers the whole of what you have in the denominator. So you can see, I also want you to take care of the brackets, the different brackets that we have. So we have the first bracket, first square bracket, we have n summation of x squared minus summation of x, the whole of that squared. Then you close that bracket. Then you open another bracket, then n summation of y squared minus summation of y, the whole of that squared. Then you close the bracket. So we see how we apply this now in the example below. So here we have this example here. So a study that was conducted, we want to establish the relationship between the weight and blood pressure of an individual. So you have this set of data. Possibly it was collected from a hospital or a clinic. So here we are taking the weight of a person, and then we also record their blood pressure. You take the weight of the next person, again you record the blood pressure, and so on. So you can see here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 10 people, 10 patients, not necessarily a patient, but you have 10 people, you are recording their weight and their blood pressure. So we want to establish whether there is any relationship between these two variables, the weight and blood pressure. Now, normally we know that, and these are cases we've seen for people possibly who are overweight. The people who are overweight, in some cases, they tend to suffer from blood pressure. So not always that they suffer, but those are the circumstances that some of them find themselves in. If you are overweight, you're likely to suffer from blood pressure. So now, so that means here we have two variables. So these two variables, like we see in the graph. So there is what we plot in the x-axis, and we refer to that variable as the independent variable. The independent variable. So the variable that we plot along the y-axis, the vertical axis, we refer to that as the dependent variable. Dependent variable. And so the independent variable is the x variable. The dependent variable is the y variable. And so here we are saying that weight is the one that always affect the blood pressure. So we want to see, does the change in weight cause any change in blood pressure? And so we take our weight to be the x variable and our blood pressure to be the y variable. With the y variable. Then our formula requires us to have all these terms: the summation of xy, summation of x, summation of y. Down here you have summation of x squared. Down here you also have summation of y squared. And so that is what now we populate here. So we have x squared. So we are just taking 78. You square, you get this. All the way down, do the same. So for y again, you do the same, y squared, all the way down, you get the values here. Then you take x multiplied by y. So x multiplied by y, again, these are the values. Then once you do that, then you get their sum below here. So this, so down here, you're going to form the summation of x. Here you're going to have summation of y. Here you're going to have summation of x squared, summation of y squared, then summation of xy. Then now you substitute that now into the formula. you substitute that into the formula. So R is equals to N. So our subjects, or the number of people we are considering, they are 10. So that will form N. Then summation of X, Y. So you can see summation of X, Y is here. Then summation of X multiplied by summation of Y. Then the whole of that divided by the square root of, again, N, which is 10. Then summation of X squared. So here, summation of X squared here. Then summation of X, but then that part squared. So here, here there is some typo here. So this 10 is supposed to be in this, where we have the cursor here. That's where this 10 is supposed to be. So there was an error in this. So this square. So this is a PDF. So I cannot edit at this point. But I will just know that there is an error here. So this 10 is not supposed to be here. So this square bracket is supposed to end at this point here. So then we have N. So just like the formula is here, N, then summation of Y squared. And then now minus the Y squared, summation of Y squared, then, I mean summation of Y, then the whole of it squared. And you get 0.5966. 0.5966. So what does this mean? You can see that this is between 0 and 1. So it is positive. It is positive. So one thing that you note is that this is positive correlation. Then again, it is between, it is greater than 0.5. 0.5 all the way to 1. So we want to establish whether this is a strong correlation or a weak correlation, a strong positive or a weak positive. So when it is greater than 0.5, so at that point you can say that we have a strong positive correlation. So say for example, if this was negative, if the value here is negative, then it means we could have a negative correlation. But now, since it is positive, so we have a positive correlation. So what does that mean? It means as the value of X increases, the value of Y also increases. As the value of X increases, the value of Y increases. But remember, what is your X and what is your Y? So your X is the weight here, and your Y is the blood pressure. So you retreat back to now the names. And so it means as the weight increases, the blood pressure also increases.